Hi, this is Perry from Reach It, and this is another draft video, and it's what I've submitted to my video team as to the videos that I want produced for you, our customers, to understand how to get the most out of the high-tech window cleaning equipment that we're preparing for you and developing. And in particular about how to go from 2 to 4 pencil jets through to 30, 40, 50 rinse bar jets, which we call Hydroblade and Hydroblade 2 now. And then understanding everything you need to know about adjusting the pressure and what does that mean and how does it reflect in the system. So I hope you enjoy this video. Okay, this video is about pressure and the next video will be about resistance. So this video we're going to talk about how to boost pressure. So again, our system looks like we have a spigot which has a hose, so from the spigot to the hose connecting to either a DI system, which will then have a hose and a tube to the pole, or we have a spigot with a hose to an RODI system, which then either has a hose to the tube to the pole, or it has a tank to a pump to a hose to a tube to a pole. So all we're going to talk about is how to increase the pressure so that we get the maximum or the ideal velocity and the ideal squirt distance. Yeah, so this is D. And it's the velocity that causes the water to squirt a greater distance. The higher the velocity through the last resistance, the greater the distance that water will travel. Okay, so obviously when we get to a spigot, it could be well water where there's very little pressure, just a home pump, or it could be town supply. If you go to different parts in the world, then it could actually just be gravity supply with a tower or with a water tank on top of a building. So there's all sorts of, this is a very big variable X. Nobody knows what it is, and that's what makes window cleaning with water pressure more complex. Now, if you only ever had one jet or two jets, it's not complex at all because you only got to squirt water through two little jets. But once you go to rinse bars and you've got 30, 40, 50 jets open, then we have to understand all of this. So here's the thing. There's two things we can do. We can boost the pressure. So we might have a pump, which is called a booster pump. And a booster pump is an AC power pump, so a mains pressure pump. And it can add anything from, a Liberty 331 might add 35 PSI, but you might get a Marathon pump with a Fluid Tech head and you could probably add 120 PSI. So this is a variable, which pump to use. There's a simple pump, just plug and play, or there's a complex pump. Simple pumps are $200, complex pumps are $600 to $800. All right, so it all depends again on the budget of the person, how complex they want to be, how much they want to understand, how simplistic they are. Is it workers versus owner-operators and all those sorts of things. So basically, normally with a DI system, because it doesn't reduce the pressure hardly at all, normally tap pressure at 40 to 60 PSI is enough to run most work, with say a tactical or whatever. So it's just going to go through, you're going to get some pressure loss, and then it's going to squirt out the other end. But if it doesn't, what do you want to do? Then I would suggest that you put in inline some sort of booster pump. Now you can use a 12 volt delivery pump and increase the flow somewhat, so you can do that, or you can get a Liberty 331 and just boost the pressure by 35 PSI. If you have an RO, then the RO is actually saving you money on the DI, like the last filter on an RO is a DI. So you're saving money on the DI by putting RO, but the RO is filtering the water, basically doing all its work for free, but using water pressure. And there goes the conundrum that we get faced. So if we look at how an RO works, basically an RO works on the basis of pressure differential. If you have pressure in here of 100 PSI and you have zero pressure out, like 1 atmosphere, which is our atmosphere that we live in, then with 1 atmosphere of pressure on this side, then you'll get the maximum performance of this RO if you have zero back pressure. Yeah, you want zero back pressure. In this case, if you want zero back pressure, you've got to deliver that water into a tank. So now all the water out of the RO is going into a tank. There's nothing pressing back on the system. Whereas if you go straight from the RO into hose, into tube, into pole, up against gravity, all of that is creating back pressure. If you have 60 PSI of back pressure being created by your system, then you're only going to get a pressure differential of 40 compared to, let's say, a pressure differential of 100. right? So that's why we would use a buffer tank. It doesn't have to be a big tank, we'll just have a buffer tank, deliver all the water from the RO into there. From the tank, we would then go into what's called a delivery pump. It's a 12-volt pump. That pump is now responsible. It's usually 100 PSI, 1.5 GPM, and it's now going to be responsible for dealing with the back pressure, which is created between the relationship and the jets and the tube and the hose coming back at that pump. So that's how we change pressure. We have to boost pressure to get more out of the system, one way or the other.